right, this is my third video for my pre-calculus class on my trigonometric identities proof lab. And like I told you earlier, I'm going to be skipping around practicing some that are maybe a little bit more challenging. And remember the rules. I want you to look at the side that looks the most complicated. Work with that rule. Don't cross multiply. Don't touch the other side. Just work with it using identities and using trig algebra and making them match. And I'm not going to lie, I love doing this. So let's look at 19. As I look at number 19, I see the left is much more complicated than the right. So I'm just going to start playing with it. And I see a squared here. And anytime I see a squared term, I start looking for an identity. And I know the identity of cosine squared is now, we've done it so much, as 1 minus sine squared theta, so I'm going to write that as 1 minus sine squared theta. If you don't know where that comes from, make sure you look at your trig identities. It comes from sine squared of an angle plus cosine squared of an angle equals 1. And I can solve for either one. So if I solve for cosine squared and move the sine squared over there, I can replace that. And that's what I did. Over 1 plus sine theta equals 1 minus sine theta. And then I look at this, and this is, you got to get used to identifying this, but this is a perfect square. This is a perfect square, and it's a difference of two perfect squares. So I'm going to go through and factor that. So I can write that as 1 plus the sine of theta times 1 minus the sine of theta. So I always tell students, if I told you that was 1 minus x squared, you're like, oh, I could factor that. Well, it's the same thing with trig functions, which is pretty cool. All over 1 plus sine theta, and I'm going to put that in parentheses, equals 1 minus sine theta. And then I look at this, and I'm so happy to see that these two are going to divide out or cancel to make a 1. So I end up with 1 minus sine theta does equal 1 minus sine theta, so I got them to match. Then I want you to do a check mark with a line through it saying that you proved that that identity was correct. Now, one of the ones on this whole lab that I think is kind of tricky is number 20, and it's got nothing to do with the actual algebra doing it. It's everything to do with which side do I do. And I'm going to tell you, it's easier for you to do this side, the right-hand side, and get it to match the left than the other way around. They both work, but I'm just going to work with the left. So you're going to have to trust me on this. So I'm going to say secant of theta, cosecant of theta. I'm not going to touch it. And then I'm going to write tangent in the building blocks. So that's going to be sine theta over cosine of theta, just to get it. And then I know cotangent is going to be cosine of theta over sine theta. So those are your identities. You can look them up, and I did them in the building blocks. And then I decided that this is one term that I'm going to go through and do a common denominator. So this is cosine theta, sine theta. And the left is still going to be secant theta, cosecant theta. Please no ditto marks, just replace it. It's okay. Now, when I have a common denominator, I see that I have cosine here. I'm missing sine, so I'm going to multiply the top and bottom by sine theta. When I do, I have sine squared theta. Here, I'm missing the cosine theta, so I'm going to use my smart one of cosine theta over cosine theta, and I have plus cosine squared theta. Now, this is a different color, but I just put this up at the top, and I said that, look, sine squared plus cosine squared is 1. I can replace that whole numerator with 1, which is so cool. So now I have, ready, secant of theta, cosecant of theta equals 1 over cosine of theta, sine theta. So we're getting close there, folks. Now, if I have it like that, I can actually pull that apart to say, and I'm probably going to run out of room, secant of theta, cosecant of theta is going to be 1 over cosine theta times 1 over sine theta. It's kind of a little math trick. And if you look at this, 1 over cosine is secant and 1 over sine is cosecant. So I end up with secant theta, cosecant theta does equal secant theta, cosecant theta, and I just got it. I just proved my identity. So here's our little math trick, is right here is splitting up the fraction so I could write it into two different trig functions. All right, the next one I'm going to do is number 21. 21, I see that the left is a little more complicated. I see a squared function right here, so I'm going to replace the squared function. So if I look at my identities in the front, so I'm going to flip to the front, so I don't want to make you sit here, but I'm going to go all the way to the front of this, and I see that tangent squared x plus 1 equals secant squared. Okay, well, if I want to solve for tangent squared x, what I'm going to do is just move this over here. So I know that tangent squared of x equals secant squared of x minus 1. So I'm just going to replace the tangent squared with secant squared minus 1. Don't forget your angles. And so I'm going to move there back where we were. Okay, so right here in the tangent squared, I'm going to put secant squared theta, not x, almost wrote x, minus 1 all over secant of theta minus 1. And that's kind of gave me the idea that then I have another minus 1 here equals secant theta. Now, again, anything with squares, I look at it and say, oh, that's a perfect square, that's a perfect square, and it's a difference of two perfect squares. So I can write that as secant theta plus 1, secant of theta minus 1. So I just factored that all over secant of theta minus 1, which is nice. Bring down the minus 1 equals secant of theta. And then I see that, yay, thanks for playing. That divides to make a 1. So now I have secant of theta plus 1. Then I got a minus 1 equals secant of theta. I'm getting excited. So now I can say those cancel out. I have secant of theta does equal secant of theta. And I just proved that identity. I just find these so satisfying and fun to do. Now, the last one I'm going to do, you've got to do all the ones in between. I try to do ones to give you an idea, is going to be number 26. So that's on the last page here. Actually, this is the last one. Okay. So let's do this one. I've got cosine of theta over secant plus sine of theta over cosecant of theta equals 1. So I've got a couple fractions here. I'm going to put everything in the building blocks, and that which means sine and cosine. So the cosine theta is going to stay. And then secant is going to be 1 over cosine. Okay, so that's in that spot. Plus sine theta is going to stay because it's a building block. And cosecant is 1 over sine of theta. And it's going to equal 1. I'm like, okay. Now, when I do this, this is a complex fraction. Again, you can say, oh, cosine divided by a fraction is the same thing as saying cosine times cosine over 1. Or, because this is a complex fraction, I can multiply the top and bottom by the common denominator, which is cosine of theta. So you end up with cosine squared theta here, plus over here, I've got the common denominator of sine theta. So these cancel here, just like those cancel here. So I end up with sine squared theta, and it equals 1. And guess what? Cosine squared plus sine squared is 1. So I have 1 equals 1, and I prove that identity. So I hope these helped. And I kind of did this video for you guys, but a lot for me because I do really enjoy doing them. And I wanted to show you how easy they are, and they're fun. And you always know they're going to match if you use everything right.